And their parallelograms have lots and lots and lots of really specific things that make them parallelograms. And today what we're doing is we are proving that we have parallelograms in the coordinate plane. So using, we're going to be able to prove that a quadrilateral is a parallelogram using the distance formula and or slope. So you get to choose how you want to prove them, parallelograms. And so there are three different methods. And first, when we have a parallelogram, one thing that we can do is prove both pairs of opposite sides are congruent. So that is one thing. We know that opposite sides are the same length. And so we can prove that in the coordinate plane using the distance formula pretty easily. So if our two opposite sides are congruent, then we will definitely have a parallelogram. At the very, very least. We can get more specific than that too. Just in case we're curious, the distance formula is what? Big radical.
Y2 minus Y1.
Okay.
X2 minus X.
I usually start with the x's. Yeah, it's squared. Very good. So x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared under a giant square root. And so what we can do is use the distance formula to prove that we have two pair of opposite sides. So if AB is equal to DC and AD is equal to BC, then we have a parallelogram. Let's see, another method that we could use is prove that both pairs of opposite sides are parallel, and that is the root of the word parallelogram, right? Parallel. And so what we can do is also we can prove that AB is parallel to DC. Segment AB is parallel to segment DC. And we can prove that segment AD is parallel to segment BC. That's a B, BC. So how do we prove things are parallel? What how do we know if we have parallel lines? Well, yeah, but we're in a coordinate plane. Parallel lines have the same slope. So we can use the slope formula. The slope formula. We can use the slope formula if we have two ordered pairs. What is the slope formula? Y2 minus Y1 over? Yeah, X2 minus X1. So we can use the slope formula. And parallel lines have the same slope. So if they have the same slope, then they would be parallel. And if these have the same slope, then they would be parallel. Which one seems easier to you, distance formula or the slope formula? All right. And then the third method is to prove one pair of opposite sides are congruent and parallel. So we can actually take and prove that not only is AB the same length as DC, but we can also prove that AB segment AB is parallel to segment DC. So if we prove that they're both the same length and parallel, then we can also prove that we have a parallelogram. So we would have to use the distance formula and the slope formula. And you get to choose today which way works best for you to prove parallelograms. But I'm going to show you one of each so you can see what you would need to do for each of those. Okay, so here we go. So for set one, we're going to use the distance formula to determine if the figure is a parallelogram. So the distance formula gives us lengths of sides. And so we want to prove that the two sides are roughly the same length. So what I'm going to do is I'm just going to make a little tiny sketch. Now in Delta Math, they're going to make you graph them, which is fine. It's easy to graph points. But let's see. I'm just going to roughly plot where A, B, C, and D are. So A is at -7, 4. I'm going to pretend that's right here. And I'm going to go ahead and label it -7, 4, just so I have the points close at hand. I think that is the nice thing to do. B is at 1, 2. I'm going to call that B, and it's at 1, 2. C is at 9, -8. That's got to be way down here. C is at 9, -8. And then D is at 1, -6. Right there. D is at 1, -6. Roughly. These are just rough, you know. So what I have here is a little potential parallelogram. And again, my picture is not to scale, but that doesn't really matter. But we have a little sketch. And we're going to use the distance formula to find the lengths of these opposite sides. So I'm going to use the distance formula here. And to start, I'm going to use A and B because I want to find the length of this side. So I'm going to use points A and B. And this is my notation for that. That's telling me I'm using points A and B. And I'm going to use my big giant square root here for my distance formula. And our job is to subtract the x's and square them. I like to just go ahead and set this up in a big little fill in the blank here. A bunch of stuff squared plus a bunch of stuff squared, all under a giant square root. All right, so I'm going to subtract my x's. I'm going to do -7 minus 1. Those are my two x values there on A and B. And then I need to subtract my y, so I'm going to do 4 minus 2. Are you with me? Yeah? Okay. So we can clean that up. In fact, you know what you can do? You can just put the... I'm going to leave the radical, but I can do everything under the radical in my calculator, all in one step. So just under the radical here, -7 minus 1 squared plus 4 minus 2 squared. So I'm just under the radical. Do you see that? If I use the radical, I'm going to get some crazy decimal. That is not what we want. Delta Math will not allow that, okay? The nice thing is you can leave it as a radical. You don't have to simplify it in Delta Math, okay? So we're going to leave it as radical 68. I don't have to simplify it. I am almost 100% positive you don't have to. Okay. All right. So all in one step, that's pretty easy to do, right? Okay. So now I know that this side is the square root of 68. I want to check that with this side over here because they should match. So I'm going to do the distance between D and C. So using points D and C, again, I got my giant square root. I'm going to set up my squares added together, set up my structure, and now I can pretty easily subtract my x's. So I'm going to do 1 minus 9. What do I have to do for my y's?
Don't put a parentheses, like extra parentheses.
Yeah, so negative 6 minus the negative 8 is really how you would do that. Could you also just minus the negative becomes positive? Yeah, okay. So negative 6 minus the negative 8. You do have to be a little bit careful. All right, so I got 1 minus 9. I'm going to square that, and plus negative 6 minus the negative 8, and square that. So again, if you're careful, you can put that whole thing in. And again, that is the square root of 68. Do they match? Good, that's good.
They won't match.
In Delta Math today? That's a good question. I don't really know. On here, yes, but we're not going to do those questions. So, now we just have to check A and D. So I'm going to do the distance between A and D. So this left-hand side here. Again, setting up my structure and filling it in. So I'm using A and D now. So I have negative 7 minus 1. And then I'm going to subtract my y's. That would be 4 minus a negative 6 minus a negative 6, which I'm just going to change to plus 6. All right, let's see. So I have negative 7 minus 1 quantity squared. Whoops-a-daisy. Squared, there we go, plus 10 squared. That would be the square root of 164 underneath the radical there. So this one is the square root of 164. And again, I don't think you have to simplify that. I will double check though. I'm pretty sure I did it and I didn't simplify. All right, and then the last side here is side BC. So again, giant square root. I'm going to set up my structure, and then I'm going to subtract my x's. So using just points B and C, 1 minus 9, and then 2 minus a negative 8 becomes 2 plus 8. This is 64 plus 100 is square root of 164 again. All right, so we have another square root of 164, which means, yep, both pairs of opposite sides are congruent, therefore parallelogram. Both pairs of opposite sides are congruent, therefore we have a parallelogram. And I do think in Delta Math there's some sort of statement like this. Opposite sides, both pairs of opposite sides are congruent, so we get a parallelogram. Any questions on that? Pretty easy? Okay. All right.
The parallelogram is equal on both sides. Why do you have to do all 4?
Because they may not be. So like this one is close but no cigar. We have sides that don't quite work. Yeah, so it's not always the case, right? You don't always have a parallelogram. So this is how we prove it though. All right, step 2. We're going to use the slope formula to determine if the figure is a parallelogram. So again, the slope formula is y2 minus y1 over x2 minus x1. So this is going to prove if we have parallel lines. So again, if we have 2 pairs of parallel lines, then once again, we're going to have a parallelogram, which the name says. So once again, I am going to create a little sketch, and you're going to have to plot these in Delta Math. So let's see. Oh, I don't want to do E, actually, because that one turns out not to be. We're going to do number 4. So at number 4, we're going to skip and do number 4. Let's see, 0, 8. 0, 8, here's point E. And again, I'm just going to plot the point and label it so that I have easy access there. 6, 10 Maybe that's about right here. F is 610. 2, 0 is maybe about right here, so this is point G at 2, 0. And H is at -4, -2 right here. So this is maybe a parallelogram. Maybe. Okay. So what I want to look at is I want to look at the slope here of this line right here using E and F. So once again, I'm going to use my famous notation here. M is for slope. E and F tell me which points I'm using. And so I am going to subtract my y's. Now this one we care very much how we subtract. So I'm going to do y2 minus y1. So I'm going to do 10 minus 8 over what minus what?
6 minus 0.
Yeah, 6 minus 0. Order matters here. I started with the 10, so we're going to start with the 6 on the bottom. Make sure you start from the same place. All right, 10 minus 8 is 2 over 6, which is a slope of 1/3. Oh, that's pretty easy math right there. Yeah, so here we have a slope of 1/3. What line do I need to compare that to? Yep, so I need to look now using H and G. So my slope of H and G, slope between H and G, again, is just a fraction. I'm going to do my y2 minus y1, so this is going to be 0 minus a -2. And what's on the bottom? 2 minus a -4, which I'm just changing to plus right off. All right, so 0 plus 2 is 2, 2 plus 4 is 6, and again, 1/3. You would need to reduce fractions, of course, in delta math, I believe. I believe. All right, so this one also had a slope equal to 1/3. Again, that's pretty nice math there, I think. All right, now we're going to look at the slope between what and what? E and H, yeah. So the slope between E and H now, so over here on my left-hand side, I'm going to do y2 minus y1, so that's going to be 8 minus a -2. 8 minus a -2 becomes plus 2. And then what on the bottom? 0 minus a -4. Very good. 0 minus a -4 becomes plus 4. So that is 10 over 4, which reduces to 5 over 2. Good. Good, good, good. And then the last pair is F and G. So we want the slope between F and G. And again, this is like just brilliant notation here, really. This is perfect. Y2 minus y1, so I'm going to do 10 minus 0 over 6 minus 2. 10 minus 0 over 6 minus 2. You see how having a picture helps? Absolutely, right? Keeps things straight. 10 minus 0 is 10 over 4, which again reduces to 5 over 2. All right? So once again, now we have two pair of parallel sides, therefore parallelogram. I guess I should say opposite sides are parallel. Opposite sides are parallel, therefore we get parallelogram. Opposite sides are parallel gives us a parallelogram. Makes sense? That's in the name. All right, questions? Is it going to take forever? I doubt it. But you only have to do it for one pair of sides. So it's kind of the same amount of work. All right, so set 3, use the distance formula and slope to determine if a figure is a parallelogram. We only have to do this for one pair of sides. So we're going to do number 5. And again, I'm just going to make a little sketch here. Let's see, J is at -9, -2. I guess that's about right here. K is at -5, 1. L is at 1, negative 4. And M is at negative 3, negative 7. Negative 3, negative 7, right there. That's interesting. All right. So again, I just have a little picture just to guide my work here. So all we have to do is look at one pair of sides now and prove that they're the same length and they have the same slope. So which sides do you want to look at? Your time doesn't look at that. What did you say, Quentin? Okay, so you want to look at this side. So we're going to look at this side, and we want to know, is KL the same length as JM? So first I'm going to use the distance formula. So I want to use the distance between K and L. So I'm going to just set up my giant radical. Set it up. Set up my structure. So I'm going to do 1 minus a negative 4. Oh, those are y's. That's fine. And then x's. Negative 5 minus a 1. Let's see, that's 5 squared plus 36. I don't know, 25 plus 36. I don't know what that is. This is too early. 61? That's not right. Oh, it could be. Square root of 61. Does anyone else do that? Yeah, okay. I also want to, since I'm using those points right now, I'm going to go ahead and also find the slope between K and L, because I might as well look at that as well. So my slope is going to be y2 minus y1. So 1 minus a negative 4 over negative 5 minus 1. So that is 5 over negative 6. All right, and then I'm going to compare that to this other side over here. I want the distance between J and M. So I'm going to set up my big distance formula. Set up my structure. I guess I normally do x's first. So I'm going to do negative 9 minus a negative 3, which becomes plus 3. And negative 2 minus a negative 7, which again becomes plus 7. Let's see, that is 6 squared, so 36 and 25. So that's going to be the same thing. Square root of 61. And then I also want the slope between J and M. So y2 minus y1. So I'm going to do negative 2 minus a negative 7 over x2 minus x1. So negative 9 minus a negative 3. And negative 2 plus 7 is 5, and negative 9 plus 3 is negative 6. So they have the same length at the square root of 61 on both sides, and they have the same slope. So this would be, let's see, one pair of opposite sides is the same length. And same slope. Therefore, we get a parallelogram. Congruent and parallel. All right, any questions for me?
Nope.
Pretty easy, yeah? All righty. Guys have a delta.